I did it. It works. I did it. 2.3. So, I'm going to teach you a lot of things about polynomials that you kind of understand little bits of it, but you don't understand everything. So let's say I had x squared minus 6x plus 5. We can factor that. We factor it into x minus 5 and x minus 1, which is x equals 5 and x equals 1. The graph of that looks like this. Okay? Well, we can determine a lot about that graph from the original equation. Okay? Because it's an x squared, I know the shape of the graph. It's a parabola. Okay? But it's also a positive x squared, which means it opens up. Okay? Well, what if I had an x to the third graph? So an x to the third can cross 3 times. Okay? So it could look like this. Okay? And it doesn't actually have to have kind of this hump and this valley. An x to the third could look like this. And instead of changing directions, we just kind of have this saddle right there. And weirdly enough, if you were driving a car on this hill, and you're driving a car, you're going up the hill and up the hill and up the hill, there is one spot where the car is totally flat. Sure. I don't know. So, and what if it was a negative x to the third? Then it would look like either like this, or, oop, that's bad, or like this. Okay. What if I changed it to 2, negative 2? That just makes it taller. Okay? Doesn't change the fact that it has those relative maximums and minimums, the change of directions. So multiplying that leading coefficient just stretches it vertically. And then all the other numbers, all of these other numbers just affect the graph's position and how tall the humps are. Does that make sense? That's what those do. They kind of slide the graph around and pull and stretch and move things around. What if I had x to the fourth? What is it going to look like? It can hit the x-axis 4 times. So it looks like this, which means it changed directions 3 times, right? So we don't really count the humps, and we don't really count the change of directions. We just say an x to the fourth could hit the x-axis 4 times. Does it have to hit 4 times? No. It might not hit at all, right? And this is really weird. Wow, it's a big bruise. Oh. I don't know, Black Widow. I think it's Black Widow. So an x to the fourth graph can actually look like an x squared graph. So it might look like this. Now, they're not totally the same. Hi. Oh, gladly. Yeah. So an x to the fourth graph is not a parabola. So a parabola is a special U shape that has a whole bunch of geometric qualities that we're not going to get into this year. An x to the fourth is U-shaped, but it is not a parabola. And if you put an x to the fourth and an x squared side by side, the x to the fourth will be taller. It kind of looks thinner, but that's a bad description. It's actually taller. Because when you raise a number to the fourth, it gets bigger faster than when you raise that same number to a second power. Does that make sense? Okay, what about negative x to the fourth? What does it look like? It's an upside down w, also known as an m. Or, so it could look like this, or it could look like that. Okay, what about an x to the fifth? Well, you just draw a graph and you hit the x-axis as many times as you need to. So we could hit 5 times. 1, 2, 3, 4, 5. And if it was negative, then would it be upside down? 1, 2, 3, 4, 5. Does it have to look like that? No. It could look like this. An x to the third. Only it would be taller. And we're not really terribly concerned about how tall something is in this class right now. So, if we did x to the 8th, let's say 80th, what is it going to look like? It could have a w, like a multiple w, right? But what are the ends going to look like? They're going to go in the same direction. They're either going to be up, up, or down, down. Ah, good. So this is an 80th, which is even, and it's a positive 80th, so it's going to be up and up. So we don't know what the graph looks like. I mean, we know that, and we know this, and then in between is a little questionable. It might just do this. That's it. Okay? Or it could also do this. Like that. That's exactly 80. I counted it. Some of them are so small you can't see. But do you understand the idea? Evens, so if this is even, then it's either going to be this and this for positive numbers, or for negative numbers, it's going to look like this. And then the middle just depends on what else is in the equation. Okay, it might just be a single loop, or it might alternate up and down a whole bunch of times. Okay. What if I had negative 10x to the 521? So because the 521 is negative, it's either, you ready for this? It's the disco. It's the disco move. Right? Which one is this? This is positive because we're going up. Right? We read from left to right. That would be going up. That would be negative. So this one's going to look like does that make sense? And then what happens in the middle? We're not sure. But we could hit the x-axis 521 times. Or 500 or 200 or 163 or 1 or 10. Is there any way for this graph to miss the x-axis? No. What about the last one? Yes, it could. What's the difference? The evens might miss because they end up in the same direction. The odd one, because it goes in different directions, has to hit somewhere. Okay? So that is called end behavior. And we talk about end behavior as the right side is going up and the left side is going down. Okay, so we'll talk about it as right and left. The right side is up, the left side is down. If it was an even number, then it would be right side is up, left side is up, or the opposite would be left side is down, right side is down, something like that. Does that make sense? Okay. Now, if I have a graph like this, and it hits the x-axis a whole bunch of times, where do those numbers show up in the equation? Well, let's do this. Okay. What is the equation for that? X plus 4 x. So x is equal to -4, -2, -1, 1, 2, 3, and 4. Actually, I don't like that one. Let's do a different one. There we go. I like this one better. Okay. So, x is equal to -5, -2, 0, 4, and 4. Anytime you get a bounce, that's a double root. So 4 and 4. So what's the equation? X plus 5, x plus 2, x minus 4, and x minus 4, but I'm just going to square it. Does everybody understand that? Any questions how I created that? All right, so let's pull this up and graph it. Okay, x plus 5, x plus 2, x, and x minus 4 squared. So I'll graph it. Man, I can't see very much. So I'm just going to times the whole thing by some really small number. Or actually, let's just divide. Let's divide it by 200. Okay, and maybe that was too much. Let's divide it by 100. There's the graph. Okay, and I can change that to fit anything I want, basically. Okay. Hey, oh wow. Thank you so much. Alphabetical?
Like Kevin, there's a couple he doesn't have.
Okay.
He doesn't have any on. Neither does Courtney.
Okay.
So,
Thank you. Oh, that's awesome. And those of you at home watching this video, you'll never know what I was talking about. That's true. All right. So, multiplying that out is going to take some time, and we're not going to do it. Yes. So, because my batteries are full. That's right. The funny thing, when that starts to go down, we're in trouble. It's the doomsday meter. Here I thought Kegley had something to contribute. Okay, so when I multiply this out, I'm going to get a big, long, messy equation, and you guys could do it, but it's going to take some time because we'd have to do the x plus 5 and the x plus 2. Then we'd have to multiply by x. Then we'd have to multiply by x minus 4. Then we'd have to multiply by x minus 4 again. But what can I figure out in that equation that would be really easy? And that is the first part and the last part. What will the first term be? X to the 1, 2, 3, 4, 5. Right? And it's positive. Okay? And then I'll have a whole bunch of stuff. What will come at the end? Well, okay. Yeah, you're going to get 0. Let's ignore this for now. But you're right. What will that last number be? It will be 5 times 2 times -4 times -4, -160. Positive 160. Okay? And then, who said 0? Why did you say 0? Because if we do x plus 0, then that's going to knock it out. So this one actually ends in an x. Okay? So, the leading term is a product of all of the variable portions of the factors. Okay? The constant is a product of all of the numerical portions of the factors. And we can use that to our advantage. Okay? If we, let's start a new page. If I had and I asked you, find all of the roots. Okay? Do you know how to factor an x to the 5th polynomial? No. I don't even know how to factor an x cubed. There are very few x cubes I know how to factor. And the reason is, every cubic equation is put in a category, and every category factors differently. So instead of learning all of the different categories, which I assume is really difficult because nobody does it, we just use tricks instead to figure out what the answers are. So if this hits the x-axis at not very nice numbers like square roots and pi and those, then factoring isn't going to work. Factoring only works when the roots are whole numbers and really integers or fractions. Okay? Or fractions. Yeah, fractions are a little bit harder, but not as hard as square roots. So, let's assume that this graph hits the x-axis in nice places. If it does, what could the possible roots be? So we have some graph. I don't have any idea what it looks like. That's too many. I know it doesn't look like that. Okay, we have some graph. And I want to know, where does it hit the x-axis? Well, what are the possibilities? 18 is a possibility. What else? -6 would be one. What about 7? 7 can't be an answer. How come? Where are we looking? Well, only part of the equation. We're only looking here. So this is what I have. Right? Where does the 18 come from? The 18 is this times this times this times this times that. So can 7 be an answer? No, because 7 does not go into 18. So none of these matter. I mean, so those numbers, they push and pull and warp the graph and slide it left and right and kind of up in diagonal directions. But if we're going to guess what the answers are, we can ignore those. And the two important things when you're looking at polynomial is, what is the leading term? What's its sign? And what's its exponent? The sign will determine, the exponent will determine if it's like this or like this, because it's even. An odd would look something like this. Okay? Uh, so that's a good question. Does the negative come into play? And the answer is yes, but it's more complicated than that because they could all be negative, or one of them can be negative and 4 could be positive, or 3 could be negative and 2 could be positive. And we're only scratching the surface here. If you look at all of the signs, which is something you'll do in 1050, there's actually more we can figure out by digging a little bit deeper. But for the purposes of this class, it's really not going to help us that much. Okay? So, the only possible answers are 1, 2, 3, 6, 9, and 18. And I don't know what the signs are. So, now, are we guaranteed that one of those will work? No. Does this graph have to hit the x-axis? Yes. But does it have to hit the x-axis in a nice place? No. So these all might be wrong. But if the graph does hit the x-axis in a nice place, those are the only possible answers. 5 cannot happen. Everybody agree? So, how do we figure it out? We just guess. And the easiest guess is always the number 1, and I'll show you why. So, to do our guess, we use synthetic division. Okay? So, I put 1 in the box, and then I write down the coefficients. Let me move this out of the way. So those are the possible answers. Okay. So 1, -6, 2, -3, 6, 2, and -18. All right. Drop the 1. -6. -6. Oh, wait. I can't do math. How about -5? And that would be -5 and 3. -3, thank you. How did I ever graduate college? Did I mess up again? Okay, what did we learn? 1 does not go in nicely, which means 1 is not a root. The graph does not hit the x-axis at 1. Now, why did I do 1 first? It's the easiest one, because if you look, all you have to do is add all these together, and you'll get the same answer. 1 minus 6 is -5, plus 2 is -3, minus 3 is -6, plus 6 is 0, plus 2, minus 18 is -16. So you can test 1 by just adding them all together. Now it didn't work. Okay? And with -1 you subtract them all. You subtract every other one. But okay, that didn't work. So I now know that didn't work. So let's try, and they're all pretty much the same after this point. So I'm going to try -2. Okay? Now, I made that equation up. What's the chance that one of these is going to work? 0. It's not going to happen, but we're going to pretend here in a second. So I dropped the 1. Some of you are sleeping. That's not good for your grade. Drop the 1. -2 times 1 is -2. And we get -8, which is 16, 14, -24. Oh, 18. That's even worse. So 36. What do you notice? Is it even worth finishing? No, this is going to be so far off. The numbers just keep getting bigger and bigger. So negative 2 didn't work. Let's try 2. Well, you're going to see that you get some help. Okay? So, drop the 1, 2, and we get negative 4. So negative 8, negative 6, negative 12, negative 15. Now, it's not going to work, but we need it to work, so just pretend. So, I'm just making these up. Or, well, whatever. And 9, and then 2 times 9 is 18. It worked. Now, it didn't really work. We're just pretending. So, what have we learned? 2 is a root, which means x minus 2 is a factor. Okay, what else have we learned? What else did we learn? 9, we don't know if 9 works, but we do know that 18 does not. How do we know 18 does not work? It's too big because that is remaining, right? So that 18 is made up of some combination of a 1, a 2, a 3, a 6, a 9, or an 18. And we found out that 2 was one of the answers. And my new equation ends in a 9. So what are my possible remaining answers? Well, let's do them in order. 1. 2's out. So once you find 1, well, if it's not a 1, if it's a 1, it doesn't really help you. No. Well, we tried 1. It didn't work. But 1 is always a possibility, or negative 1. But do you see how finding 1 makes finding the others easier? Does that make sense? Because it narrows it down. So then, I'm going to choose one of these. Let's try 3. Okay, and it probably won't work because I just made this up. But we put a 3, and then I use these same numbers here. So drop the 1. 3 is negative 1. No, I'm going to do the math wrong on purpose. Yeah. So I'm just going through 9, negative 7. This ends up being a 6, a negative 6, so 5. Negative 5, and we get negative 3, and I get negative 9, and I get 0, which is not true. So I now know that x plus 3, or x minus 3, is one of the factors. Okay, and what else have I learned? The only possible remaining factors are 1 and 3. Okay? And we really just guess until we get it figured out. So what is your assignment going to look like with respect to that? Well, it's not so bad. Hang on. Not today. Okay. So number 1. What does this graph look like? It's a positive x to the third, which means it looks like this. It can have 3 roots. What could they be? So the factors of 32, 1, 2, 4, 8, 16, and 32. Okay, and this one's actually more complicated because it starts with a 2, which means you might have a fraction. So it could be 1 over 2, 2 over 2, 4 over 2, 8 over 2, 16 over 2, and 32 over 2. But most of those are already there, right? The only one that's new is that one. All the others are there. So we can get rid of those. Okay, so which one do you think is the answer? Well, let's try 1. 1 is always the easiest. So look at that equation. If you add those numbers together, the coefficients, do you get 0? So if we do 2 plus 8 minus 32, do we get 0? No, so 1 didn't work. Okay, so pick a different one. 2. Well, let's do -1 and I'll show you how it works. So am I missing any coefficients? No? 2, 8, -8, 32. You made it. Drop the 2, -2, we get 6, -6, we get -14, -14 is not 0. It would just be 14. Oh, sorry. Yeah, still not 0. Okay. So how does the -1 work? You just alternate every other sign. So you would do 2 minus 6 and then plus so you change the sign on every other one, which is kind of complicated, so you might not want to do that. Okay, that didn't work. Let's try another one. So was my answer way off? Not terribly off. So do I want to go all the way to 32? No, maybe we just go to 4. So we put 4 in, 2, 8, -8, 32. Drop the 2. It's negative, thank you. So 8, 16, 64. Is that going to work? No. So let's try -4. So -4. So -8, 0, 0, 32. Boom! Got it. So what have I learned? I know x is equal to -4. What else have I learned? X minus 4 is a factor. There are 2 more factors. Okay, but oh man, I'm all sorts of off today. Okay, is anybody stuck so far? Okay, now the nice thing is, yeah, Abby, you a little confused? So, what about my remaining 2 roots? My remaining roots are a 1, a 2, a 4, or an 8, which means the 16 and the 32 option are out. Okay, but let's be smarter than that. Oh, I must have done the math wrong before. Whatever. So, what is our remaining equation? What do we have left? It's a 2. That's supposed to be a 2. So my remaining equation is 2x squared minus 8. That's just a quadratic. Once you have it down to a quadratic, let's just use our factoring rules. So I'm going to pull out a 2, and I get x squared minus 4. How does that factor? X plus 2 and x minus 2. So, once you get it down to the x squared, then just factor. And so 2 works, so I must have messed up when I did that. We didn't do 2? What did we do? Oh, we skipped 2. Oh, sorry. Okay, so let's look at another one. We should have done 2. That means I would have had to listen to Kegley, and I make a point never to listen to what Kegley says. Okay. Oh, look at this one. That one, number 5, is easy. Because I know what number works. 0. How do I know 0 works? There's no constant. So I'm just going to get rid of an x. And I get 3. I need 3x squared plus 3x minus 18. Pull out a 3. X squared plus x minus 6. And then I can factor it. So that one I didn't need to use division. No, that one's the same way. I'll show you. Okay. Look at number 13. What could the roots be? 1, 4, 2, and 1, 2, 4, and 8. Everybody see that? So here's what you do. You pick 1, 2. Oh, well, first, let's try 1. Would 1 work? 2 plus 8 minus 2 minus 8 would be 0. So that one would work. So you could do that one really fast. Okay? Or you could try a different one. Let's try 2. 2, 8, negative 2, negative 8. Drop the 2. 4, 12, 24. It's broken. We might as well try negative 2 while we're here. So drop the 2. Negative 4, 4, negative 8, negative 10, negative 20. That one didn't work. Positive 20. Doesn't work. Yeah. Okay. Well, let's try 8. So 16. What do you think? Is that one going to work? No, definitely not. So let's do 1. Well, it worked, but we didn't know what the end equation was. So 2, 10, 10, 8, 8, 0. So 1 worked. Or negative 8. Or if you look, everything here has a 2 in it. So you pull the 2 out. I bet it's 4 or negative 4 that works. Anyway. No. So I end up with 2x squared plus 10x plus 8. How does that factor? Hey, pay attention. Pull a 2 out. X squared plus 5x plus 4. That's x plus 4 and x plus 1. So x is negative 4 and negative 1 and 1. So you really only have to guess once, and sometimes you don't have to guess at all. Okay? Do those problems make sense? Kind of? That is so true. Okay. Yeah, you could have pulled the 2 out to begin with. Okay. What if I had this? What if I had a polynomial and I asked you this question? Choose the end behavior. And it didn't show up for some reason, so let me show you what it actually looks like. Oh, it logged me out of Alex. So for some reason the PDF is blank on that question. So I'll show you what it actually looks like. Okay. All right, number 2. Number 2 says choose the end behavior. So this is a negative x to the 6th. So negative x to the 6th will have what endpoints? The left side will be down and the right side will be down. So falls to the left and falls to the right. That would be the correct answer. Okay? This one is a negative 2x to the 3rd. So we do the disco move. Which one is it? This one. So the left side goes up and the right side goes down. Okay? All right, what about C? So C is a little bit complicated. We have to count the x's. How many x's are there? 1, 2, 3, 4. And then we have to look at the signs. They're all positive, which means it's positive. But what if I had this? How many x's are there? 1, 2, 3, 4, 5, 6. What's the sign going to be? Just count the negatives. How many negatives are there? 2 here and 1 here. 3 negatives makes a negative. So what would that graph look like? Down and down. Okay, that's pretty easy, right? Yeah, that's what the video's for. Yeah, you can hear me. You can't hear you. Okay. So, this one says, consider the following polynomial. Answer the questions regarding this graph. So, we have a negative out front. I have 1, 2, 3, 4 x's. So this is a negative x to the 4th, which means it looks like this and it looks like this. where does it touch the x-axis? At -1, 1 twice, and 2. So if I draw that graph, we're going to hit at -1, we're going to bounce off 1, and then go through 2. Yeah. So, well, this negative flips it upside down. Okay. And then -1 only appears once. 1 appears twice. And 2 appears once. Well, it does, but it also changes the constants. So whether you had x minus 4 or -x plus 4, you end up with the same root. So the practice is make all the x's positive, and then if you need to flip it upside down, just put a negative at the beginning. Okay, so you'll go through and you'll answer the question. Where does the graph cross the x-axis? It crosses at -1 and 2. Where does it touch? It touches at 1. And then how do we get the y-intercept? We do a little bit of math. More specifically, where is this number going to be? That number is the constant. That number is going to be this times this times this times this, and you have to factor in that sign as well. So negative times 1 times -1, or I got it backwards. No, that's right. Negative times 1 times -1 times -1 times -2. That ends up being +2. So this is -x to the 4th plus 2. This tells me the shape of the graph. This tells me where it hits the y-axis. Okay. And then you have to graph it, which is pretty easy. So what do we know? Well, I know, maybe. So this, it hits here, and it's this one. It hits here. Okay. It hits here. Hold on, that point's in my way. It hits right there, and it's a bounce, an upward bounce. It hits right here. Okay, and it hits like this. Okay, is that all that we need? Oh, now we need to draw the graph. There we go. Does that make sense? Oh, let's check it. Oh. Try again. Recheck. Did it say? Oh, okay. Yeah. All right, and then lastly, the next question, I believe. So you'll be given a bunch of graphs, and it will ask you which one of these function matches which ones of these graphs. So this one here, it has a bounce at -1, and it goes through 3, and it's going to look like this. So it bounces at -1, and it goes through 3, so it's going to be D. Okay, and what does the other graph do? Well, we have to factor it. X squared times x minus 3. What does that graph have? It's a bounce at 0, and it goes through 3, and it's this version of the disco So that would be one thing I didn't teach you guys. This is actually x to the third. What does a triple look like? So a single root goes through, a double root bounces, and a triple root makes a saddle like that. So this is a triple root at 0. So it is in fact A. Nope, it's not A. It's E. Because it's an x to the fourth, so it has to be up and up. So we have a saddle at 0, and then it goes through 3. So that would be A. Oh, E. Not A. Yay! Continue. And then I think, okay, yeah. So where does this graph hit the y-axis? So what's the constant? This one does not have a constant. So it hits the y-axis at 0. And then just factor it to find where it hits the x-axis. Okay. That's it.